We are going live to solve a LeetCode problem, algorithmic problem. Hello world, my name is Alan. I'm preparing for algorithmic interviews and I'm sharing my life coding, streaming it. Today we're looking at this medium level problem, number of enclaves. Basically, we are given a matrix grid with zeros and ones. And in this problem, we need to count how many cells do not have connection with the border. So there are cells that are connected and they are not just the cells, but I mean the islands that are connected. Yeah, so how many cells are on the islands that are just not connected with the border? And I think I solved an opposite problem where I've recently solved it, where you were supposed to count those that are connected. But in this in this case, we can do either. We can go either way because because we can just deduct the total number. By the way, in that other problem, we were supposed to I think we were supposed to capture those islands or return the list of them, of those cells. In this case, we just need to count them. To count those that are, like in this case, it's 3. This one is on the border. Yeah, this one is here at 0 because all of these are an island that has a connection with the border. So, one way to do it would be to, we can count and do and traverse each of these islands. We can go around the border, traverse those, each of those islands and count their cells and then deduct that out of the total number of cells. So in this case, it's 4 and total is 4, so we'll get 0. And in this case, in the first example, it's 4 minus 1 is 3. Or we can actually, can we do it any other way? Or we can just go over the middle. Yeah, avoid the boundary, go over the middle, inner grid, and check out each island if it and count it only if it's connected with the border. It's not connected with the border. So we'll count it, and then we'll count them into the final result if it's not connected. If it's connected, we don't. So either way, basically. If it's like 500 by 500 in the worst case, if we just go over the perimeter, we need to go over just 500 4 times. But if we go inside, we'll need to go over pretty much 500 by 500 each of them, and check. I mean, we can also one thing we can do, we can also use that grid to track visited. For example, we can mark the visited with zeros, basically, or something else, so it's not a 1 anymore. Yeah, in that case, we will not do duplicate work. Yeah, even if we go through this full square, we will not be visiting any multiple times. Yeah, we'll just know, we'll be checking each island only once. So I think it doesn't really matter. Yeah, as long as we use that trick, yeah, to check the visited, to track the visited, I mean, then check it. Then either of these approaches is fine. This one just seems to be naturally shorter, probably. I mean, we do need to go over the entire matrix and count all the ones initially. We need to know how many total ones there is. Then we'll need to count those adjacent ones and do our deduction. So we will need to go 5 by 5, 500 by 500 anyways. Yeah. If we go through the inner grid, we will, our check, when we go around, we will need to check if any of the cells is on the border. So we'll count. If it's on the border, we don't count that in. I would say it might be a little bit more. I mean, it sounds like it's just easier to check those that are on the border and deduct them, because you already know it's on the border, so you don't really need to worry about it. You don't need to do those checks. Like, okay, because for each, you'll need to do 4 checks, like the top, the bottom, the right, and okay on. Or no. Wait a second. You will not like that. You will just know. Okay, is the the position of it, like this column and row, is it the first row or the last row? Is it the column, first or the last column? Which is basically the same thing. Yeah, it's 4 checks. It's fine. Yeah, but when we go over the perimeter, we just don't need to worry about it. Yeah. So let's count the total. Total is 0. We'll go over for row. And by the way, the grid, we know that the rows is length of grid. Now that the calls is length of grid and 0. And for row, range rows, or basically length of grid. For column is range length of grid 0. And by the way, how should we do? Yeah, now we're just going over all of them and counting total. Right, so we're just gonna say that grid row column, if that thing, we don't need to even worry about it. We'll just say that total is total plus that value. So now we'll know the total. But there is another thing we'll need. We can do at the same time. I mean, we can check. If row is the first one or the last one. Yeah. So while we are at that, we can also do if row is 0 or row equals rows minus 1, or column is 0 or column calls minus 1. So that that is the first row. That is the last row. Yeah, that's first column, last column. So if any of that is true, we are on the perimeter. Then we should do our traversal then we can say, okay, if grid RC, row column is 1. Yeah, so we found it. We need to count it. Yeah, so that's total. That is, the way that we can just call it rows. This one we can call it columns. So we have total, but we'll also we'll count this border. Border will also count. So if we have 1 there, now we need to trigger this traversal and mark it all with, count it and mark it with zeros. And by the way, I don't think we should do it in the same loop, same traversal of the grid, because we first want to count it, total of it. Yeah, I think we should simplify it a bit. Like let's separate these, because yeah, we got our total. Now we'll do a separate traversal and check if it's and count those border islands. Yeah, because, and at the end we'll just return total, minus border. Yeah. Why? Because if we start changing the visited, I think we'll be missing. Yeah, because what will happen, we'll hit a border island, we'll go traversing on it, changing it all to zeros. And then when we go over it back on our traversal, we'll not count it. So yeah, it's just easier to do it separately. Let's not complicate things. Then we just need to pick the type of traversal we want to use to go over that island. And so let's see. We can do breadth first search naturally, like this one. Yeah, we'll just go over the adjacent ones. Or we could also do depth first search, right? Could we? Like, yeah, we could. Could we do depth first search, like this, like, and when we visit it, once we visit it, we want to turn it into, flip it into 1. Yeah, but we will check all the adjacent ones. For some reason, I think that both DFS and BFS are applicable here. Why do I think so? Why do I think so? Yeah, with DFS, you will just go to like this one, it will reach this one, this one. If if we were going over zeros, like imagine those zeros are actually ones, so let's like the reverse. So we'll go like this one here. If it starts with the left, like left top, like clock. If it starts clockwise, like top, right, bottom, left. Okay, it will go bottom. Now it will go to the right. We'll go to the bottom. We'll go to the bottom, to the left. It will go to the top. It will go to the top, and this one will hit where there is nothing to flip, and we will return. And that will be a recursive solution. Could be a recursive solution, yeah. I'm not sure that using recursion on is the best idea on like 500 by 500. So that's like 25. Yeah, 21 to, yeah, it's 250,000 calls potentially. You can create a stack of this high. It's probably better to do it iteratively. So let's do it with a queue, I guess, with BFS with a queue. In this case, we'll start. The BFS will go like that. We'll have a queue, which will be some kind of it's two numbers basically. It's this position. So it's a slice of slices of integers, okay? And it has this, inside of it, it has this slice of integers. Oh, and by the way, that all needs to happen inside here. So if there is one, so we will, we'll say, oh, by the way, it's gonna be so nasty. I mean, so heavily indented. Yeah, the indentation is gonna be crazy now here. So we might wanna abstract this thing out. And that will entail, so BFS, create a function that will do this whole thing. So we'll just feed it this position. Say, okay, here is the grid. Here is where you need to start and reverse. And give me back the count. Yeah. So it reverses all the ones, and it's counting them. So we need to pass the greed. Yeah, like BFS will get the greed. It will get position, or I mean, we can just say it will get the row and column type integer. It will return an integer. Since we are given it a slice, so it will be updating. We'll be working on the same underlying array. So that's kind of the definition of this function. And func, and we will call it with rc greed, and that thing we'll just add to the border plus equal that, the result of that function. And inside that function, we will have queue that will have, that queue will have this slice R and C, this position, and it will work with the grid now. So for length of queue is more than 0, yeah, we will we'll go that this neighbors, and by the way, there is for each has maximum of 4 neighbors. Each cell has a maximum of 4 neighbors. So we need to go get those neighbors. But I mean, it's gonna become longer. Yeah, because we'll get like to this one, then again, if we go look at zeros, get this 0, it will then we'll pass this one. This one will pass these ones will pass these one. This one, yeah. So so yeah, we have this position now. We found this number. It's queued up. We need to know how many neighbors. Yeah, neighbors, or let's call it because I mean, we are going to just count them and flip them. That's all we're gonna do. So, and by the way, we have about 30, yeah, we're 30 minutes into this. Size is length of queue, that we need to remember that. Queue, and we're gonna go over for range size. Yeah, we just need to go over this number of, get those out of the queue. I'm gonna say that now is queue 0, queue is queue 1. So we got our now, this position. Now we need to go over its neighbors. Which is pretty much now. Yeah, so row, column, do we need to? Well, that's, yeah, now 0, now 1. Yeah, row. So what we need to do is we need to check the neighbors. We know that now is 1, but we need to check the surroundings and yeah, we need to check this now 0. It's our row. And the column is now 1. So let's look up. And by the way, we're on the border all the time. Oh, not all the time, only the first time we start on the border, but yeah, but I mean, yeah, this is our position, but we want to try this row -1 position, and this column. Yeah, we will try that in the grid, but we need to make sure that it's not outside of the boundaries of the array. So we need to check if row is more than 0, we'll do that check. Otherwise, yeah, we can't do that. Yeah, we can look at the top. If row is more than 0, then we're gonna say, okay, what is up there? Yeah, if that's a 1, get that value. Yeah, that's a 1. Then if that's 1, then we need to do something. First of all, we need to append it to the queue. Queue is append queue and this position. this slice of integers with row column. If it's, yeah, and we also need to flip it. Yeah, we also need to say that grid now is 0. But yeah, basically we're gonna go there, but by the way, we don't need, I think we might not need this extra. Yeah, and yeah, if it's more than 0 and it's 1, then we do that. And that's same thing for all other directions, basically. Yeah, if row is less than a length of grid -1 and grid row +1 +1 column is 1, yeah, we're also gonna, by the way, we're gonna enqueue the one. Yeah, we're gonna enqueue that, and we're gonna row +1, and we're gonna say it's now, yeah, well, wherever, oh no, we're not gonna say that. No, when we are at 1 and now is this, then we're gonna say here that the grid row column, yeah, is 0. Here, yeah, we're gonna flip it, not in each one. Yeah. So, but these ones, all they do is they just enqueue them. Yeah. And if column is, so that means we can try and see the column. The next column. Oh, previous, yeah. And if, yeah, we enqueue that. If it's 1, yeah. If column is less than length of grid Then we say that, yeah, that we append it to the queue. By the way, we also count, we also do the count is 0. So every time we have a 1, we say count ++, and that's what we need to return. So every time we're in the queue with something, so we'll go through this initial value, get all of its neighbors available. Yeah, we just here need to say that it's plus. Yeah, if it's less than, then and it's, yeah, Okay, maybe it's not the best readability, but count plus plus. But it's sort of, it should be, oh, return count. Return count. So this is our BFS. It's a bit messy because I think, I don't know. Yeah, so what it does, it looks at if there is room to go, yeah, it checks it and it goes and it should do invalid operation. Where is this? Oh. Yeah, there is this if is less, is if column is less than length. Yeah, so if there is room to go, we're gonna check what's in the grid. Oh, I see. Yeah, so we're gonna check what's in the grid and yay, test case and all the cases. Wrong answer. Output minus 40. Ouch, 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 ouch. Use test case. Well, what could be wrong here? So we bumped into some negative value. So we counted, the border had counted more than there is. I wonder where we actually, because we only look at the ones, if there is a one, but every time we hit a one, we actually flip it. We flip that. So we have the now, count it, count it, and we flip it. Till we turn it into 0. So in the grid, it should be 0 after that. And that grid is the same. We're passing it to BFS. This grid is being passed. Because what we do in the first we count the total before we do anything else. So we know the total is this. Then we go over the perimeter. Yeah, if it's a perimeter cell. Only if it's a perimeter cell. And if it's 1, then we pass it to our BFS. Along with the grid, and that grid is being updated with each element in the queue, item in the queue. So initially there is 1, and what will happen Because, yeah, what they're asking about is those that are not on the border, and we are counting those on the border. Yeah, the total is any ones. So we'll be done and we'll have the total. Yeah, so then we have this. The good news, it worked on these 2 test cases. That's good. But it's somehow not working. So it worked here, but somehow it's like overcounting those border cells. So if it sees a border, I want this on the border, it goes calls our BFS on it. So it goes like, okay, count is 1, we're in the queue. As long as the queue, there is something on the queue. Okay, go over it. All the values on the queue, and we enqueue all those. Gonna enqueue all of those that are ones. But I mean, the first thing we do, we say, okay, now we're on this specific cell from the queue. It has these coordinates. And okay, we're gonna count it because it's a 1. And we're gonna also switch it in the grid to 0. It's not 1 anymore. But we're gonna go over all of its neighbors. Anyways, yeah, we're gonna check all of its available neighbors. Yeah, if there is row, if we are not at the first row, we're gonna check above. If we're not at the first row, we can check above. By the way, there could be just 1. Yeah, the length could be just 1. But yeah, I mean, if it's the first row, we're not gonna do it. But if there is more rows, yeah, we're gonna check above, row -1. If there is something, yeah, we'll compute. If there's nothing, we're gonna pass it. Okay, if there's something and it's 1, we're enqueuing it. We're saying, okay, put that on the queue. Put that specific position on the queue. And that, yeah, if it's not the last row, we check the row below, yeah. Also putting that on the queue. If it's not the first column, we check the column to the left. And enqueue it if it's 1. If it's not the last column, we also check the column to the right. And we enqueue that column if there is 1. So yeah, we put those in the queue. And do we need to do anything else here in that loop? We went over all of those neighbors, And we're checking if there is something on the queue. If there is, okay, we're gonna take one of those neighbors, count it, and so on. I wonder what those. I don't see a bug yet, but print line total. I want to see the total. I want to see the border. But I wonder what they are because. My initial thinking is, yeah, we have 40 of these, but it looks like we're counting a lot of extra ones on the border. It looks like it's just not updating them, like not be updating them. Yeah, we might want to do like print the matrix. Well, we want to print each value. But I mean, at the end of the row, I want to print. Yeah, I want to print each value and print like. Yeah, we can do it like that. But we want to print. Or at least just print line at the end of it. By the way, let's print. Yeah, let's print the matrix before and after because it's just hard to read it. Let's print it before and then print it after. Yeah, so before. Yeah, so this debugging obviously takes could take a lot of time. So after, but I mean, I just want to kind of understand what it looks like. So it looks like there is tons of, yeah, all of these are border values, but there is still 40 of them. And we have after all the border ones are cleaned, but it looks like they're counting more. Yeah. No, okay, so the good news is it's actually cleaning them. So after all the iterations, it's cleaned it. It's cleaned. So I think it should be along the way. Yeah, why would it like count it to several times? That's the thing. Because it flips them all it flips them every on every once it gets on the this, for example, so it will start with this one and yeah, so it will start with this one, it will flip it and enqueue this next one. This next one will not count this one because it's already 0. That's what we want. So it will look around and enqueue this one. This one will enqueue that one, and so on. But we should not get any double counting. Which is kind of the idea, and the fact that at the end of it, it's all zeros. And I mean, we only count when we have a 1. So if grid in that position has a 1, 1, 1, 1, then enqueue that and we'll do that and then count. Is there any problem with like count starts with 0? So for each node that we find, we return this number and then we add it to the border number. We add it to the border number. But that only happens, I mean, when we call this BFS. BFS counts, but it will also change it. Yeah, it will. So we shouldn't have 87. When we have 40, when we have 40, total 40 ones, how did it get to 87? That's the thing. Where did it get them? One problem could be this, the visitor doesn't work. Because it counts only to the size in the length. To the size in the length, that's all it gets. We can actually even just say, like, instead of doing that, we can just say count plus size, right? Oh, what's missing? Oh, we somehow deleted a return. Return total minus border. Yeah, and we know that total and border still there's 40 extra. T and line total border. Yeah, how did we get this extra 40? I wonder, is the traversal right? Because what's happening for each row, we'll go like row 1, for row 1, we'll go over all the columns, 1, 2, 3, 4, or 0, 1, 2, 3, actually. And that will happen. And the same thing here. Yeah, but there's just when we're in the inner, just not going to do anything. I'm going to skip them. Yeah, if it's outer, if it's the perimeter, yeah, if it's border. If row is 0 or column is 0, that's 0. If row is last one, rows minus 1. The last row. Column first, or column is last one. But then we check, okay, if in that position we have a 1, so give me the number of these ones in that island, and while we do that, we flip them. Like we'll look at this one initially flipped. Grid RC is 0 now. But we are going to get its neighbor. That will be column plus 1. So initially there will be just that. When we go on that neighbor, we also flip it. So when we go on that neighbor, this one is already 0. We don't have to check it. We only go there. Yeah, there is. So it looks like there's somewhere this little bug, maybe in some of these coordinates. Rows go from length, from 0 to length of grid minus 1, right? And columns go from 0 to length of grid 0 minus 1. It looks like there is this little bug somewhere. It's just not purely visited immediately on the fourth test case. It's not clearly visited, I mean. Okay, I think, yeah, I mean, for practice purposes, I guess this is a good video. I mean, I can try like another 10 minutes to try to find the bug. Yeah, and let's try that and we'll finish it up. And so where could it be? Why is it counting something several times? Each call, each node before we go to its neighbors is turned into 0. So we counted and it's 0, but we even count them before. So yeah, we'll look at its node and look at the node and turn. It's flipped to 0. The node is 0. So when we grab all its neighbors, so when we're working on a node, it becomes 0. So we're not gonna count it. Count them again. They become zeros, and we only count those. So on the queue, is the queuing working fine? Okay, queue is 0. Is the first, so the queuing is taking queues that starts from 1. Starts from 1, yeah, so we cut the queue. And yeah, and we'll get the row and column from now, and we work with it. Yeah, but that's just what we need from that queue. That's all we need, and then we put something on that queue. Queue is append. So we're putting these additional nodes if they are ones. Okay, how can we use like logs or something to track the problem, to catch the bug? One way we could like catch where the border becomes, like at which position the border all of a sudden becomes more than the border becomes more than at which point, yeah, it becomes more than the total. It might be, I don't know if that will show us anything. But yeah, so what else we can do? I mean, we can look at we can look at the certain I mean, we can look at this. Yeah, at the moment, we can find the moment when like if border is more than total, let's put it that way. Yeah, print us the, let's say I want to see what the matrix looks like at that moment. Yeah. And probably want to see what it looks like before that. So it's like at breakpoint, or at border more than total. And we also want to print it before, so before, that's like initially, basically. Yeah. By the way, we broke the entire thing. Wait a second. If border is more than total, wow, if border is more than total, we're only printing it. Oh, yeah, we're accent, we're returning something. Yeah. So before it was like that. Oh, and it started. Yeah, so before it was like that. And then at the breakpoint, so it cleaned this and these, and it looks like, so it has these left, and it's already bigger. By the way, at the next call, when it's bigger, wow, so it looks like if border is bigger in total, if border is bigger, oh, wait a second, sorry. Yeah, we do need that to happen at each line, and we also want that at the end. I'm not seeing much difference. Know what I'm saying? Like this thing doesn't change. And is it supposed to be changing? So what happens, we're going over the matrix and we're calling it. So, and each call should update the matrix, but it's not really changing it. So it's like, it should, like it shouldn't, yeah, these it's not gonna touch, but now it should be cleaning like this one. And it's not cleaning them. Okay, at some point, like on the third try, it cleaned this one on the left. Okay, then we have three loops of with this one, I don't know, like then it's some number of loops. Yeah. Oh, with, yeah, like with this one, then some number of loops. Yeah. And only then we catch that one. Ouch. So we are repeating a lot of, so this is happening. Oh, well, it's going over all the perimeter. That's why it's printing every time, not just when we hit the one, when we actually hit, yeah, we need to print it only when we hit a one. We shouldn't be printing it otherwise. When we hit a one, okay, now it's shorter. Okay, so, okay, we have that, then this one is deleted, this one is deleted, and this one is deleted. Okay, now I want also to see, so I want to, at the end, I want to print it the total, and I want to print it the border, and I want that to happen after each, yeah, after each of those. Yeah, so this one, yeah, at the end we know. Now, okay, before we go there, it's already 78. Oh, geez. What happened here? Oh, gosh. So it's actually jumped over. It just jumped. Mm-hmm. So it looks like it was working on this figure. Yeah, this one. And this one created that, this big number. Yeah, this thing created this big number for some reason. Instead of just being counted like as 20, like 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's 22. Oh, why is it? It's 22 there, but it gives us like 78. So somehow this thing is being like over calculated, like for some reason. I mean, yeah, we can trigger that. We can detect that jump with if we just print not, yeah, without this, like if true, yeah. Just give me all of those, yeah. Oops. Oopsie daisy. So it's, yeah, it's going fine, and then it just jumps. Yeah, there is a bug somewhere here. Then it's, yeah, it's 14. It's 14. Then it flies up. Because this is an island, this is an island. This, yeah, this one is adjacent. And by the way, we will trigger it, yeah, like this. We'll be going over the, because we're going over, we can only catch it here. Yeah, we'll go over the, we'll start from this one over the perimeter. We'll start from this one. By the way, tomorrow is Saturday. We start here, and our BFS gets us this one. This one goes here and here. These are all zeros. Then this one is done. This one gets this one. This one gets this, this, and this. So for some reason, when it traverses this figure, it calculates like, you see this, 64. It calculates 64. So what I'm observing, it does do well with updating the so the grid is updated. Okay. The grid, as we log it, it's been updated. It is being updated. By the way, yeah, before it's 0, then it finds first 7. 7 is 1, 2, 3, 4, 5, 6, 7. This first one, yeah, is removed. 7, then it finds 5 more. It's this 5. Yeah, why? What's the problem with this figure? I don't really understand why it can't do this figure well. If the if the grid is updated, the grid is updated. Oops. What else is so size is always new. We can print the sizes, but size is the length of the queue. Length of the queue. For there's something on the queue. Okay, it's 1:30 minutes I've been when I've been trying, but it looks like, yeah, we pretty much solved it within the 40 minutes, and now it's another it's been more than 45 minutes plus 45 minutes, 90 minutes. Yeah, we've been trying to find this bug for the rest of it, so I think it will probably catch up tomorrow with it, but I think that was a good attempt. The solution is not going to do, it's not doing stack overflow, not overflowing the stack. So overall, it seems like a promising solution. And so I think we should wrap up, and I'll try to find that bug and pick up on this tomorrow. Or yeah. So good try, good practice. Thank you for watching. Like and subscribe, and we'll see you in the next video.